Okay, hello YouTube. We have our little EMF, electric field, magnetic field tester. And we're not going to measure EMF, we're going to measure EF, electric field strength. So we have it set to volts per meter mode. This is just the potential voltage that exists wherever electricity exists. Not all electricity, but specifically alternating current or static electricity. For example, I'm wearing polyester fabric, and I have this meter here, and I'm going to be just rubbing my shirt sleeve a bit, and I worked it all the way up to close to 300 potential volts per meter. I didn't feel a thing. That wasn't the type of static electricity where you feel a shock or even a charge. That was just a little bit of building it up. So the numbers on this meter being high don't necessarily equate to any thing dangerous. It is a relative measure of potential electric field strength. So it's rather high when you come in close proximity to this touch lamp. The kind that you touch as the switch. And when I'm touching it, there is no electric field because I'm in direct contact with it. There is always a current going, so it's radiating. It's an alternating current. And because it's radiating, there's the baseline measurement. If I bring my hand in between it, I'm going to be blocking all of that, or absorbing it. If I have my hand nearby the meter, by the electronics, can you see this? The numbers will actually go up. Take my hand away. The thing shut off. Let us turn it back on. Volts per meter. Let's move it a little bit closer. Baseline 140, 120, 80, 70. I'm going to have my hand nearby the lamp. It goes lower because my hand is absorbing that. But if I bring my hand by the meter, it throws off the measurement. So, the presence of my hand, myself, affect this meter a little bit. Let's do some experiments. So there's also a USB charging port, which I think puts out some extra voltage. And I have on my table a glass of wine. It's in a plastic glass, actually. And it's reading 90, 100, 120, 150, 180. Is it because of the plastic on the glass? 180, 200. I was not expecting that. Move my hand away. Remove the glass. Move my hand nearby again. Replace the glass. Moving my hand nearby with the glass there. Oh, that's crazy. I did not expect that. Let's put this here. Baseline distance. Baseline measurement, about 20. I will not touch the meter. This is a supposed, they call it soapstone, harmonizing thing. It's slightly magnetic, I know that. I'm going to put it just like there. And it reads a 0 while my hand is touching it. I move my hand away. It's reading 18, and our baseline was about 20. I'm going to rotate it so it's right now in contact. Let's just move this. And that went up to 60. And then I moved my hand nearby, touching the meter. And that goes right up. It was just a magnet. And the light being on doesn't affect the reading. Good old magnet. It's blocked completely right there. That seems to be lower than it was. I did scoot it away a bit. Okay, this is a shungite cylinder. Put that just like there. It rolls towards it, makes contact, and we're reading 60. Right in the middle. Scoot the meter back a bit. Shungite, soapstone. Meter. Another piece of shungite. Meter. Let's try, just for stuff and giggles, this, orgonite pyramid, which is just a nice pretty paperweight. I'm going to put it right there so the copper coils and the crystal are right there. Meter. Houseplant. I'm going to move that magnet out of the way, lest it affect the experiment. Houseplant. Lamp with ambient electric field. Meter. Ready? Meter by itself. I am holding it. We get about 200. I'm nearby the shungite too. About 130. Now the soapstone. Now the shungite again. And the pyramid. The apex of the pyramid. How about the base? Now, are you ready? Here's the air. Right here's the air, about 40. Now I'm going to move over by the plant. Oh yeah. Get in that foliage. We've got excessive potential voltage. Just the life force energy of this plant combined with the radiant electric field from the lamp. I scooted the plant back a little bit. That is just nuts. Let's look at the soil. Let's stick the probe in the soil. So, what's going on? Crazy. And I started out, I believe, with the glass of wine, which surprised me very much. And I think, whatever effect is happening, it's the same for the glass of wine as it is for the plant. There's this glass of water sitting here too. It happens to have some black rocks in it, but I don't think their presence is going to affect the reading. 120. Well, let's put the same type of black rocks just on the table right there, at about the same spot, at about where we would be reading. And it is less. The water, which is in a glass carafe, 70. Down at the shungite at the bottom, marginally higher. Over here, much higher. Up in the plant, come on. Well, you get the idea. And just for control, this effect will not happen when the plant is by itself, and it will not happen with humble direct current voltage. Here is a regular voltage lamp. We can pick up that AC current. We can pick it up coming from the base. That's actually very strong, isn't it? What if I put the plant right here? Milligauss microtesla voltmeter. Here we go. See, same thing's not happening. So what's going on? What is it, man? What is it? Life force. Electric fields. A single leaf. Does that make it higher? Take the leaf away. So the shungite, being in close proximity, there's the shungite, there's my field strength, 140. Okay, ready? There it is again, move my hand away. 50, 40. Remove the rocks. The presence of the shungite rocks slightly increases the measurement of the ambient field at that point. I don't know if it's the water that increases the effect more here, but I believe the stones at the bottom probably increase it a bit. 200 is pretty high. A similar distance without the carafe. Right up next to it. Okay, it's higher there. And then we get back to the glass of wine, which has darn near the same, if not a greater effect. But I wonder if that's because this is actually a plastic glass. which wouldn't make any sense because the plastic shouldn't conduct that field. It's going to go right through the plastic and it's going to be interacting with the water and the stuff in the water. But what is going on with the plant? I want to know.